Alright, so this next video here is going to be talking about parallel lines and their angles. When we have parallel lines and they are crossed by what's called a transversal, we get special angle relationships, okay? And parallel lines happen all over the construction site. At least they should be happening all over the construction site. Otherwise, you're going to have some issues, okay? So, obviously, the reason why I picked this picture here is you have a lot of parallel lines, okay? Lots and lots of parallel lines. All of these wall studs are parallel lines, and then you could consider these top plates as being your transversal. Or maybe you'll see a board that goes across like this. We've done that before to basically cross brace when you're putting something up. Maybe you haven't sheeted it yet, so you end up cross bracing it to make sure everything stays in place. That would be considered to be a transversal. Okay, so on this next slide, we're going to get a little bit mathy with it, just traditional math, and then we'll apply it in the construction setting as well. Alright, so what we have here are two parallel lines, and the way that that's notated in math is they put an arrow on it. Let me see if I can do a better job. It's a little better. Okay, so those two lines are parallel. That's what those two arrows on the lines mean. Alright, that's how you notate it in a traditional math class. Okay, and then this line running through those two parallel lines, that's referred to as my transversal. Okay? Now, these angles that I've numbered 1 through 8 have special relationships with one another. They have special names for them, and when those lines are parallel, you get congruent angles, and you also get supplementary angles. And the great thing about this is it is what it looks like. Okay? So, let's start. Alternate interior angles. Alternate interior. Well, my alternate interior angles would be something like 4 and 6. And what do you think you know about those angles? They are congruent. And that'd be angle 4 congruent to angle 6. Angle 3 is congruent to angle 5. Alright, those are all alternate interior angles. Lovely. Let's try another one. How about alternate exterior? Alternate exterior. Which ones do you think those are based off of that first one we talked about alternate interior? Well, my alternate exterior angles are going to be something like 1 and 7, or 2 and 8. And what do you think you know about those? You got it. They are congruent. So it's angle 1 is congruent to angle 7. Angle 2 is congruent to angle 8. Awesome. So those are your alternate exterior angles. And we've got one more pair, or one more set of angles that would be congruent when you have parallel lines. Even though I just kind of ruined it there, saying that they were going to be congruent. Oh well. So we have what's called corresponding angles. Corresponding angles just means they're like in the same position. And our corresponding angles are indeed congruent. This would be something like angle 1 is congruent to angle 5. Those are corresponding angles. Or 4 and 8 would be congruent as well. They'd be a pair of corresponding angles. Got a couple more, don't we? Angle 2 and 6. There we go. And angle 3 and 7. Awesome. So those are my corresponding angles. And you'll actually find that the corresponding angles show up probably the most frequent in the construction site, I'd say. We'll see it in a few examples here shortly. Alright, so then we also have our supplementary angles. Our angles, they're not congruent when we have parallel lines necessarily, but they are supplementary. Those are our same side interior angles. Same side interior are sup. They know what's up. Alright. Which ones do you think our same side interior angles are? Those would be our 3 and 6. So angle 3 is sup to angle 6, and also 4 and 5. Angle 4 is sup to angle 5. Okay, so those are our same side interior. And you guessed it, we can also apply that to our exterior angles as well. Okay, let's do that. Let's see if I can find another color here. How about this fancy color? Here we go. All right, so we have same side exterior angles, and they are once again supplementary. So that'd be like angle 1 is sup 2, angle 8. Those are same side exteriors. Or how about angle 2 is sup 2, you guessed it, angle 7. So we're on the same side of the transversal. That's what the same side refers to. And we're on the outside of the two parallel lines. That's what the exterior refers to. And you can apply that to all of these. Alternate sides of the transversal, interior of the parallel lines. 4 and 6 are on alternate sides of the transversal, which is this guy. And they are on the inside of the parallel lines. Okay? That is pretty neat. Oh, again, probably the most common one is going to be our corresponding angles. We're going to see those quite frequently. All right, so where are our parallel lines here? Where are the parallel lines? Well, if you said the wall studs, you'd be absolutely correct. These are my parallel lines. At least they should be if framed up properly, right? We would make sure that they are all what's called plumb, like the vertical version of level. Okay, you can use your level for that. But we want to make sure that they are all plumb, and we'd know that they are all parallel. So I have a question for you. What do you think we know, and I'm going to zoom in here as best I can, what do you think we know about these angles? What kind of angles are these? Well, if I just isolate it to a couple, let's do that first, okay? So you've got this one, and this guy up here. That was terrible. These two top plates that are going up there, up the rafters there, that would be like my transversal. The two vertical ones, these would be my parallel lines. What types of angles are 1 and 2? Now, if you remember what I said on the previous slide, the most common ones that we're going to see in construction, corresponding angles. Corresponding angle. And what do we know about them? You guessed it, they are congruent. All right, so yeah, all of these angles follow that corresponding angles. Okay, because they're all those parallel lines. You get that one big transversal running all the way up there. But all those angles should be congruent. They are corresponding angles when you're talking about parallel lines here. And they should all be the same angle. You can use that when you're framing this up. You know you're cutting on the same angle when you're framing up these wall studs. Awesome. All right, now what's wrong with some of these pictures? I see many things wrong, but let's go in the context of what we're talking about here with parallel lines. Do these guys look to be parallel? Don't think so. One of the main things I see, even also down here, notice how my widths down here compared to up here are definitely different. I see some other issues as well along the way that we could talk about more of in a construction setting. I'm mainly focusing on the parallel lines right now. Also, look at this. Very small up here, a bit bigger up here. You can see that they're going up on kind of an angle. They are not plumb. So they're not going to be parallel to each other when you're talking about like this one and then this guy or this guy and then the other one that's going to be running right along here. They're not going to be parallel to each other. You're going to have issues when you are, sheeting this, siding this, putting, whatever. You want to have your studs running vertical. You want them to be plumb. You want the studs to be parallel to each other. So a follow-up question, what would not be true here? Okay? If they are indeed going up on a, if this guy's kind of out of whack right here, what do you think, and I'm going to zoom in a bit, what do you think is not true about, like, say, this angle and this angle. If this stud is going up on a slant compared to, say, this one or any of the other ones, what's not true about these angles? Well, these angles, they are not going to be congruent. They're corresponding, but those lines aren't parallel, so they are not going to be congruent. Okay, so those angle relationships, that when they're saying that they're congruent or angles are supplementary, they only apply when the lines are parallel. Okay, so that would be my transversal. But yeah, they would not be congruent if that board's going up on a slight angle, if it's turned, if you will. Once again, guys, what's going on here? This wall looks like all sorts of jacked up, doesn't it? I mean, you could clearly see the width here and here. They're all different. These guys are, oh my goodness, right? They're not parallel. That's the main thing we're trying to get across here when connecting parallel and our construction class wall studs. Okay, when you're running things, they should be running consistent with each other. You're making all those boards parallel. If they should be parallel, you got to be checking that. The distance between these should be the same all the time, because if these studs went on to infinity and beyond like a line would, you want them to never intersect each other, right? Never cross. That's what it means to be parallel. Okay, so again, our angle up here and here, not going to be the same, right? These angles are going to be different if the boards are not parallel to each other, if they are not plumb, if they're not vertically level, all right? So we got a nice little complicated looking diagram here. Let's see, what can we get into with the angles here? All right, let's just say let's say this building is symmetrical as far as the rafters go, right? We'll cut it right down the middle. This is the same as that length over here. All right. It says over here, it's hard to read, but the slope is 512. Okay, so it's a 512 pitch that takes us back to that unit, right? So it's a 512 pitch. Cool. Well, what do I know about my angles here? Well, obviously down here at the bottom, should all be right angles, right? That was a nice voice crack. I'm going to leave it in there because I'm crazy like that. So these should all be right angles down here at the bottom. What do we know about all of these angles going up? Will these all be the same? I would say so. These are all going to be corresponding angles as you go from inside each one right there, right? And that'll all be based off of that 512 pitch if you want to figure out that angle. Okay? We could do that with a little bit of tricky trig, but we will do that shortly as a little bit of review in the figuring out, framing up some roof trusses. Woo! That sounds awesome. But yeah. All right, so if this is done right, those angles going all the way up here should be the same. These should all be the same down here. Lovely, lovely. Then you know that all these are indeed parallel. All right, so we got ourselves a nice little application problem. Back in the day, Tupac loved doing home renovation projects. One of his favorites was building a studio in the backyard. Now, picture below is half a truss. The other half will be the same thing, so we got to think of it as it'll continue on this way, right? Making a gable end roof. Okay. Tupac always had trouble finding the angles he needed to make the cuts. Can you help him figure it out? R.I.P. Tupac. So, find and label the angle size of all interior angles of the roof truss. Round in the nearest whole degree. And all boards that look parallel are indeed parallel, and all angles that look 90 are 90. Okay? Those are the things we can assume. This roof has a 512 pitch. Woo! 512 pitch. We were just talking about that in the last problem. So if I want to figure out angles, any of you guys remember how to figure out, let's go with this first angle, the angle that it's going to make right here. How am I going to figure out that angle right there? Well, if it's a 512 pitch, remember we can set up a nice right triangle to figure out that angle. I know it's rise over run, which is 5 over 12. Well, if I'm looking at it from this angle, we'll call it theta. 5 is my opposite. 12 is my adjacent. I'm using tangent, but because it's finding an angle, I'm doing inverse tangent. And when I plug that into my calculator, I get 22.619 blah, 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 So we'll call it 23 degrees since it says round to the nearest whole degree. So we'll call it 23 degrees. Cool. Now, can we figure out all of the other angles? I think we can. I'm going to bring this up nice and big so we don't have to write too small on it. So we got the 23. We're good to go there. Let's figure everything else out. Well, what else are we going to have? This, let's see here. I'm going to try and draw on some parallel lines. So I know that this guy, where did my green marker go? Is parallel, running parallel to this guy, right? Okay. And let's think about this right here as being my transversal. Well, this angle, 23, and this angle right here, those are, you guessed it, corresponding angles. They're in the same position, so they are the same degree measure, 23. Perfect. That's fantastic. I love it. I love it. Okay. Well, what else are we going to have here? Well, as we said in the directions, what appears to be parallel is in fact parallel. So these guys labeled W3. All of these are parallel. So parallel, parallel, and parallel. We already know that these guys, I'll do 2 arrows. Those ones are parallel. All right. Well, now if I'm looking at this line and this line, and I consider this to be my transversal, let me draw another little extra picture here. This line, boom. I've already got 23 here. What's going to be right there? Also 23. So this is 23, and the same concept applies over here. 23. All right, I got a whole bunch of 23-degree angles. Oh my goodness, there's even more here, guys, and I'm not going to draw on this too much more because it just starts to get like real crazy. But you've got, again, parallel, parallel. Now this is my transversal. So what do I have up here? Boom, 23. And the same concept applies right here, 23. What kind of angles were those? Because we've only dealt with corresponding angles thus far. These ones that I just labeled are alternate interior angles. Okay, what we dealt with was a situation that looks something like this. That diagonal one is my W3. Let me draw it maybe a little more slanted so it looks more accurate to the picture. And what I had was this angle and this angle. Those are alternate interior angles. They're on alternate sides of the transversal, and they're on the interior of my 2 parallel lines. Woo! It's awesome. Alrighty. So I've got my right angles. I don't need to worry about those. However, do you guys remember how many degrees are in a triangle? There's 180 degrees in a triangle. That is correct. So if this is 90 and the other angle is 23, what's left over for this angle? That would be 67. And the same would apply to all these other guys because there's all these triangles here. 67, and we'll do 2 tick marks for that. And 67. Those guys are congruent. Whee! I don't think I need to do all this, but we will. 67, 67, and 67. So I've got all these different angles just based off of parallel lines, corresponding angles being congruent, alternate interior angles being congruent, and also the sum of my triangles are 180 degrees. Sum of all the angles in a triangle are 180 degrees. That's right. Now Jenny just pulled in a little bit closer here as she's taking a nap. She's checking out my TI-84. I'll pop another picture in for you. Oop, there's Jenny. She's just hanging out. Eee, look at how cute she is. She's wanting to use the calculator. Actually, I think I'm putting her to sleep. All right. So Ja Rule, if you guys don't know Ja Rule, he's a pretty awesome rapper from back in the day. Ja Rule's building a web truss which is pictured below but needs some help figuring out some missing lengths and angles. The web truss creates rhombi and triangles between those parallel boards. Okay, so we got rhombi, which is the plural of rhombus, and we've got triangles. So, what do I know about my rhombi? Well, the rhombus, let's see here. It's exactly like a parallelogram, so it's all the properties of a parallelogram. Opposite sides parallel, opposite sides congruent, blah, 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 blah. But even more specific, all the sides are congruent. Okay, and my diagonals are perpendicular bisectors to each other, but I don't think that's going to apply here so much as the sides being congruent. So if all my sides are congruent and one of them is 13.5 feet, what's x going to be? X is going to equal 13.5 feet. And I know that because all the sides are congruent in a rhombus. All right. Well, what do I know about my opposite angles in a rhombus? It follows much like a parallelogram, or exactly like a parallelogram. So these guys are 72. And then, more importantly, what's this guy? Because I'm pretty darn sure that's going to match up with my y. All right, well, what do I know about the consecutive angles of a rhombus? It follows from a parallelogram. The consecutive angles add up to 180. They are supplementary. So if that's 72, this is 72. Why don't we work within one rhombus? 72 plus y is equal to 180. And I can just go ahead and subtract the 70 dose. Y is going to equal 108. 108 degrees. And I got my x. Awesome! That was quite exciting. Indeed. Let's see here. I've got a question for you. Maybe a little follow-up. Just a little follow-up fun. So I'm going to do this in the new purpley color that I've been working with. So these are all the same rhombi that are going through here. We've got our triangles. And if I know that's 108, that y is 108. And all the angles that correspond to that y, right? This guy here with this guy here with this guy here. Right, those are all congruent. What do I know about this angle right here? Or here? Or here? Well, it's going to be supplementary to it, right? Because that makes a straight line. Cool. So that's going to end up being, well, what's supplementary to 108? 72. I mean, that's just how we just figured out the 108, right? It was supplementary. So if that's 72, I'm going to go a step further. What is this angle's measure? And would it be the same as this guy here? I believe so, because all of these lengths are congruent, so we basically created this isosceles triangle. Woo! So my legs are congruent. The base angles also have to be congruent. My goodness. Well, what's left for the rest of that triangle? Well, 180 degrees in a triangle. If you subtract 72, you get 108. What's half of 108? Because I got to divide it up equally, right? I get 54 for each one. So this is going to be 54. Oops. And also this guy here is 54. Okay. That's pretty exciting. I'm going to get even more crazy with you children. Ready? These guys are parallel, right? Well, what's this angle's measure right down here? If you guess that it's going to be 54 as well, you are correct. But why is this 54? What kind of angles are those? What kind of angles are these two? What angle relationship do they have? Well, they are on alternate sides of this guy right here, this transversal, right? They're on alternate sides of the transversal. They're on the inside of the parallel lines. These are alternate interior angles, and we know they are congruent. Awesome! That was super cool, rad, and fun, finding all sorts of interesting lengths using parallel lines, properties of quadrilaterals, just awesomeness in general, getting mathy, YOLO.